Hi guys, here's your video going over 7.4 partial fractions day 1. So after you are done watching this video, you should be able to decompose partial fractions. So before we actually start the process of partial fraction decomposition, and I actually tell you what it is, I wanted to go through one of these types of problems. So just simplifying rational expressions. So I have 2 over x plus 5 plus 3 over x minus 4. Now anytime you are trying to add fractions together, you always need a common denominator. So if I look at my first fraction, I have x plus 5 in my denominator. My second fraction, I have x minus 4. So I'm going to take my first fraction and multiply it by my other denominator, so x minus 4. And of course, whatever you do to the top, you have to do to the bottom. And for my second fraction, I'm going to take that and multiply it by x plus 5. Okay, now from here, I'm going to go ahead and distribute the 2. So that gives me 2x minus 8 plus, distributing the 2, and then distribute the 3. So 3x plus 15. And that is all over my common denominator of x minus 4 times x plus 5. I can combine like terms, so that is 5x plus 7 over my common denominator of x minus 4 times x plus 5. Okay, so what the heck does this have to do with what we're doing today? So today with partial fraction decomposition, we are starting with this problem right here, and we want to get to our 2 fractions from the original problem. So essentially we are undoing the process of adding rational expressions together. Okay, so here is our first example. Our first example, we're looking at linear factors. So part A, x plus 7 over x squared minus x minus 6. So the first thing that you need to do is factor your denominator. So 2 numbers that multiply to negative 6 and add to negative 1, that is negative 3 and 2. Now again, our goal is to separate our original problem into fractions. Each one of these factors, the x minus 3 and x plus 2, is going to get its own fraction. So my first factor of x minus 3 is going to be the denominator of my first fraction, and my second factor of x plus 2 is going to be the denominator of my second fraction. Now, our goal is to figure out what these numerators are going to be, so these are a giant mystery right now, so I'm going to call this capital A and capital B. Now from here, what we're going to do is we're going to do the same process that we did with this problem, where we actually added our 2 fractions together. So I want to add these 2 fractions together. So in a similar manner, I'm going to take my first fraction and multiply it by x plus 2, my other denominator. Same thing with my second fraction. I'm going to multiply it by x minus 3. And of course, whatever you do to the top, you should do to the bottom, because that's how fractions work. But at this point, I really don't care about the denominator, because we already know the denominator is going to be this. What I do care about is the numerator, because I'm trying to figure out what a and b are. So I'm going to ignore my denominators for now, and I'm just going to focus on my numerator. I'm going to rewrite it. So I have a times x plus 2 plus b times x minus 3. And that numerator is supposed to equal my original numerator, which is x plus 7. Now from here, I'm going to work through my distribution. So I'm going to distribute my x, or not distribute my x, distribute my a. So that gives me ax plus 2a plus distribute my b. So bx minus 3b. And of course, that's supposed to equal x plus 7. Now, after I've done all the distributions, I don't have any parentheses left, I just have a bunch of terms, I'm going to start to look for like terms. So I have ax plus bx, and that's supposed to equal x. Keep in mind, if there's no number in front of your x, it's like having a 1 there. So that means ax plus bx should equal 1. So I'm going to use that to set up an equation. I don't know why I wrote the letter b. That should be a plus b equals 1. Now continuing to find other like terms, I have 2a minus 3b, so neither of those terms have x's, so that means it's my constant, and that should equal 7. So I'm looking at my like terms. So 2a minus 3b should equal 7. Now what you have left is a system of equations, which you can solve a couple different ways. You can solve by substitution, you can solve by elimination, you can also use the calculators, which makes it a lot easier, by using the RREF. So I'm going to go ahead and set up my augmented matrix. This one is a 2-variable system, so I have 1a, 1b equals 1, 2a minus 3b equals 7. And in my calculator, I'm going to do the reduced row echelon form, so RREF, typing that in, and that is going to give me a second, I'm going to put it into my calculator. It's going to give me this as my result, so 1, 0, 2, 0, 1, negative 1. And of course, from what we know about the reduced row echelon form, you should always have the identity matrix over here, and if that's the case, then that means this last column is going to be your solution. So I'm going to go ahead and write that as an ordered pair, so 2, negative 1. Okay, so how does that help us? Well, that told us what A and B are. So A is 2 and B is negative 1. So going back to the original problem, our goal was to figure this out, what A and B are, so I can write out my fractions. So now that I know A is 2 and B is negative 1, I can write out my final answer. So that's 2 over x minus 3. And since B is negative 1, I'm going to do minus 1 over x plus 2. And that is your final answer for this problem. All right, let's do another one. So looking at this problem, again, my first step, I'm going to start by factoring out my denominator. So I have an x in common, so I can take out an x. That leaves me with x squared plus 2x minus 3. That can be factored further, so that gives me x plus 3 and x minus 1. And this is my factored denominator. Just like I said before, each factor is going to get its own fraction. So I'm going to have a over x plus b over x plus 3 plus, and we had a third factor, which means we're going to have a third fraction, c over x minus 1. Now, in order to figure out what you're going to multiply by, you should always compare this denominator to this right here, because that's supposed to be my common denominator. So my first fraction of a over x has x in the denominator. What it doesn't have is the x plus 3 and the x minus 1. So that is actually what I'm going to multiply by. So I'm always multiplying by what's missing. And then for my b fraction, I have the x plus 3, so I have this piece. I just need the other two factors. So I need x and x minus 1. So I'm going to multiply this by x and x minus 1. And then for c, I have the x minus 1. What I'm missing is the x and the x plus 3. So that is what I'm going to multiply, x and x plus 3. Now I'm going to go ahead and rewrite this because I think it looks a little weird and I still need to work through the distribution and whatnot. So I'm going to rewrite it as a times x minus 3, x plus 1, plus b times x and x minus 1, plus c times x and x plus 3. All right. Now I'm going to start to multiply my pieces. I'm going to multiply these two. I'm going to go ahead and distribute the x and distribute the x. So I'm dealing with all of my x's first before I do any sort of a's, b's, and c's. So when I multiply x minus 3 times x plus 1, that is going to give me x squared plus 2x minus 3. I'm going to distribute the x. that gives me x squared minus x. I'm going to distribute the other x, so that gives me x squared plus 3x. And now I'm going to distribute my a's, b's, and c's. So I have ax squared plus 2ax minus 3a plus bx squared minus bx plus cx squared plus 3cx. And of course, that is supposed to equal my original numerator right here. So that is supposed to equal 4x squared plus 13x minus 9. So I'm going to write that down for, oh, wrong color. 4x squared plus 13x minus 9. Okay. Now, it looks like a lot, and it is a lot. We got a bunch of terms, but now we're in the home stretch. I'm going to go ahead and look for my like terms. So I'm going to start by looking for my x squares. So I have ax squared, bx squared, cx squared, and that is supposed to equal 4x squared. So that's my first equation. So a plus b plus c equals 4. Now I'm going to look for my x's. So I have 2ax, negative bx, 3cx, and that's supposed to equal 13x. So that's my second equation. So 2a minus b plus 3c should equal 13. And then everything else, let's see, I'll use green. I have negative 3a, oh, and that's it. And that should equal my constant. So negative 3a equals my constant, which is negative 9. And then from here, you can use the calculators with the RREF. Here's my augmented matrix, 1, 1, 1, 4, 2, negative 1, 3, 13, negative 3, and it doesn't have the b or the c, so I'm going to go ahead and put in zeros, and negative 9. Once you do that, plug it into the calculator. Your calculator is going to give you the solution 3, negative 1, and 2. And then once again, that is your A, B, and C, and we can write out our final answer. So it was A over X, so 3 over X. B is negative 1, so minus 1 over X plus 3. Plus 2 over x minus 1. All right, so that is when your denominators are linear factors. Now let's take a look at what happens when your denominators are quadratic factors. So here is our last example, quadratic factors with partial fraction decomposition. What happens with quadratic factors is there's one slight difference, which I will point out as we work through the problem. So again, I'm going to start by factoring out my denominator. They have x's in common, so I can take out an x. So that leaves me with x times x squared plus 4. Now x squared plus 4 is not factorable. It doesn't factor any further, so we're just going to leave it as x squared plus 4. And again, I'm going to go ahead and separate this to two fractions since I had two factors. So my first denominator is x, second denominator is going to be x squared plus 4. And this is when the difference comes in, because with the other examples, we did not actually have an x squared in the denominator. So what that means is that is going to change what we have in the numerator. So for my first fraction, I'm still going to have a. That didn't change. For my second fraction, since I have a quadratic denominator, that means I need to have a linear numerator. So what that looks like is bx plus c. So the only time you need to do this, I'm going to make a little note over here, is when you have x squares in the denominator. So if x squared in the denominator. So when that's the case, you need a linear numerator, which is when you're going to have that bx plus c. Otherwise, if you don't have an x squared in the denominator, then you're just going to have your a, your b, your c, like we had with the other examples. And then from here, everything else is the same. So for my first fraction, I'm going to multiply this one by x squared plus 4. And for my second fraction, I'm going to multiply by x. Because again, I'm comparing to what's over here and looking at what's missing, and that's what I'm going to multiply by. I'm going to go ahead and rewrite. So I have a times x squared plus 4 plus, I'm going to put bx plus c in parentheses because it's an expression, times x. And then I'm going to go ahead and work through my distribution. So I'm going to distribute my a. That gives me ax squared plus 4a. I'm going to distribute the x over here. That gives me bx squared plus cx. And of course, this is supposed to equal my numerator, which is 3x squared plus 4x plus 4. Let me write that down, 3x squared plus 4x plus 4. And now I'm going to look for my like terms. So I'm going to start by looking for my x squares. So I have ax squared, bx squared, and that's supposed to equal 3x squared. So I have a plus b equals 3. For my x's, I have cx equals 4, so c equals 4. And then finally, for my constants, I need another color, blue. That should equal 4. So I have 4a equals 4. Now, if you look at the way that I wrote the system, I have everything spread out. That's just because I wanted my variables to line up. So I have my a's, b's, and c's all lined up together. If you wanted to use the augmented matrix for this and put it into the calculator, that's okay. However, this particular system is actually a lot quicker to just do by hand. I'm just setting up my augmented matrix while I talk. Keep in mind, if you are missing any variables, you're putting zeros there as placeholders. So that's what the augmented matrix would look like. But if I look at my system, I can solve for a, b, and c right away. So take a look at this. Again, your goal is to get that ordered triple. I already know c. c is 4. And then if I look at this equation in blue, 4a equals 4, that's going to help me solve for a, so that means a is 1. And if I look at this equation in purple, a plus b equals 3, and if a is 1, that means b has to be 2. So there is your a, b, and c. But again, if you wanted to plug it into the calculator, you could. I'm not going to stop you. So for this one, a is 1, so I have 1 over x plus, and bx plus c, so b is 2, and c is 4. All over x squared plus 4. All right, so that takes care of partial fraction decomposition with linear factors as well as quadratic factors.